In this video, we're going to apply the substitution method to slightly more difficult examples. So the first example, find integral pi over 6 to pi over 4 tan x dx. Let's start by rewriting tan x as sin x divided by cos x. So we have integral from pi over 6 to pi over 4 tan x dx. This is equal to integral from pi over 6 to pi over 4 sin x over cos x dx. Now, when we usually solve these questions, we let u be the inside function, but here there is no inside function. So we have to think about it. If we let u be equal to cosine x, the denominator, the derivative of that will give us minus sine x, and that takes care of the numerator. So that's our motivation. So let u be equal to cosine x, du is derivative, is minus sine x dx. So we can write minus 1 du, dividing both sides by negative 1, is equal to sine x dx. We need to change the limits. So let's change the x limits to u limits. X equals pi over 6. We plug that into u is equal to cos x. And we get u is equal to cos of pi over 6. Cos of pi over 6, that's, we can get that from the special triangle. That's going to be adjacent over hypotenuse. That would be root 3 over 2. X is equal to pi over 4. U is equal to cos x. Plug that into u. U is equal to cos of pi over 4. And we can look at the special triangle, the 1, 1, root 2 triangle. Cos of pi over 4 is adjacent over hypotenuse. That will be 1 over root 2. All right. So what we have is integral pi over 6 to pi over 4 sin x over cos x dx. We can rewrite this as integral from pi over 6 to pi over 4 1 over cos x times sin x dx. Our substitution is u is equal to cos x. Du is minus sin x dx. So minus 1 du is equal to sin x dx. We transform the limit, so x equals pi over 6 was transformed into u is equal to root 3 over 2, and x equals pi over 4 was transformed into u limits. U is equal to 1 over root 2. So we can rewrite the integral as integral from root 3 over 2, the lower limit, the lower u limit, and the upper u limit is 1 over root 2. And 1 over cos x, so here we have, this is going to be 1 over u, sin x dx, that is minus 1 du. All right, so what we get is 1 over u times negative 1 du. Minus 1 is a constant, passes right through the integral. We get negative 1, integral root 3 over 2, to the upper limit 1 over root 2, 1 over u du. Let's integrate this, and we get minus log of absolute value of u from root 3 over 2 to 1 over root 2. Since both of the u limits are positive, we don't need the absolute value. So I will rewrite this as minus log of u from root 3 over 2, lower limit, to upper limit, 1 over root 2. Minus log, applying the fundamental theorem of calculus, plugging the upper limit in, we get log of 1 over root 2, minus log of root 3 over 2. Let's distribute the minus sign, and we get minus log of 1 over root 2 Minus times minus gives us a plus, plus log of root 3 over 2. So what we have shown is that the integral from pi over 6 to pi over 4 tan x integrated with respect to x, that's equal to minus log of 1 over root 2 plus log of root 3 over 2. All right, let's look at another example. Here we have integral x to the 5 third root of x cubed plus 1 dx. So we're going to let u be the inside function, u equals x cubed plus 1. Du is equal to 3x squared dx. And 1/3 du is equal to x squared dx. Let's rewrite this integral as third root of x cubed plus 1 times x cubed times x squared dx. Now we can see how x squared dx, this part, can be replaced by 1/3 du. This part of the integrand, that's just going to be third root of u. But the question is, what do we do about x cubed? How can we replace that? If we go back to the original substitution, u is equal to x cubed plus 1, we can see that we can algebraically solve for x cubed in terms of u. That's u minus 1. So this part is u minus 1. We now have the entire integral in terms of u, and it will be solvable. So we have integral. Let's pull the 1/3 out. And we have u to the 1/3, write it as a fractional exponent, times u minus 1 du. That's going to be 1/3. Let's multiply out the 1/3. We get u to the 1/3 times u to the 1. That's going to be, they have the same base, add the exponents. 1/3 plus 1, that's going to be 4/3. Minus u to the 1/3 du. Let's split up the integrals, and we get 1/3. Integral of u to the 4/3, we add 1 to the exponent and divide by the same number. So we get u to the 4 over 3 plus 3 over 3, that is 7 over 3. Divide by the same, that means multiply by the flip, multiply by 3 over 7. Because dividing by 7/3 is the same as multiplying by 3 over 7. Minus u to the 1/3, so take the 1/3, add 1 to it, we get 4/3. And divided by 4/3, that's equivalent to multiplying by 3 over 4. Let's add plus c. Now let's replace u by x cubed plus 1. So we get 1/3 times x cubed plus 1 to the power of 7/3 times 3 over 7 minus x cubed plus 1 to the power of 4/3 times 3 over 4 plus c. We can now simplify a little bit. 1/3 times 3 over 7, the 3's cancel out, and we're going to get 1 over 7 times x cubed plus 1 to the 7/3 minus, and 1/3, this 3 cancels with this 3 here. We're going to get minus 1/4 x cubed plus 1 to the 4/3 plus c. This is the answer to the integral. All right, let's look at another example. Here we have integral 2x sine minus 1 of x squared divided by root of 1 minus x to the 4th. We know that the derivative, d dx, of sine minus 1x, that is just 1 over root 1 minus x squared. So we're going to apply that. Let u be equal to sine minus 1 of x squared. Its derivative du would be 1 over root of 1 minus inside squared, we get x squared, all squared, and then multiply by the derivative of the inside, applying the chain rule. That means multiply by 2x times dx. All right, let's simplify this a little bit. We get du is equal to 2x divided by root of 1 minus x squared squared, that's x to the 4th, dx. Alright, let's rewrite this integral as integral sine minus 1 of x squared times 2x divided by root of 1 minus x to the fourth dx. Now this part of the integrand, sine minus 1 of x squared, that is the substitution u. And all of this, 2x divided by root of 1 minus x to the fourth dx, that is just a differential du. So it's now going to be very easy to solve this. We have integral u du. And reverse the power rule, we get u squared divided by 2 plus c. Substitute u back in, and we get sine minus 1 of x squared all squared divided by 2 plus c. Alright, I want to talk about the chain rule a little bit. So if you have d dx of sine minus 1 of g of x, where the inside is a function of x, we get 1 over root of 1 minus inside squared, g of x squared, multiplied by the derivative of the inside, derivative of g of x, that is going to be g prime of x. Alright, thanks.